Hi everyone, so in our last video we discussed 5-layer AI architecture. Despite having all 5-layer architecture deployed in production, what happens is applications fail. During pilot project they work, but when we deploy them on production they fail. It's not normal though, but what happens is under the radar there are certain pitfalls which should be discussed. So today we are going to discuss those 7 mostly common pitfalls. After we discuss 7 common pitfalls in real development environment, it might save months of debugging at your end. Welcome to Thinking in Systems. I'm Swapnil Tripathi. On this video, we break down AI architecture, decision frameworks, and long-term thinking for serious builders. So let's move forward and discuss all our pitfalls first. So if you see here, we were discussing about these 5-layered architecture earlier. Now we will move forward and discuss what kind of pitfalls we can fail. So here I have mentioned all the pitfalls, their remediations, their reasons, how to handle them. Everything is mentioned here. We will move forward one by one. First is context rot. So what is context rot? So basically what happens if we talk about context rot, so it happens at orchestration layer, or we can say we will fix it at orchestration layer. So in context rot, it is nothing but let's assume we have implemented a system, and a simple example could be agent is working on your salary. It works, everything moves forward. It is able to calculate your salary, decide the data. But at last, what happens is it somehow forgets to upload your tax documentation. So these use cases are common where actually old context can be forgotten by an agent. Now the question is, how do we handle it? Since we are talking about context, we should handle it at orchestration layer. hmm? So that if there are any kind of history limits, if we want to increase them, if we want to handle how many histories can be remembered, all those things can be handled at orchestration layer. How do we do that? So basically what happens is at orchestration layer, we can implement memory checkpoints so that we can keep on checking how many memories needs to be added, how should we handle it, and then we can have context summarization based on multiple prompts or maybe zero shot prompting. We can handle it. So if you see here, if text document is submitted true, then skip upload request, right? Otherwise it will check. So based on this we can handle context rot. Now let's move forward and talk about second pitfall, which is prompt tuning overload. Now what is prompt tuning overload? So if we want to implement any AI system or any agent, first of all what we do is we plan to create summarized prompt, or we want to create refined prompt. Now, if we do it manually, that means we will have to do it multiple times, and then it is a cyclic process. We will refine a prompt, we will test it, again we will find some issues, then it is a cyclic process, right? So it takes time, and there is, we don't have a guarantee that it will be done for like it, we will be able to get achieve it almost 100%, right? So if you see here in this diagram also, I have mentioned we create prompt 1, then it keeps on repeating itself, and it is not guaranteed that we will have it almost 90 to 100% accurate. Now how do we handle it? In order to handle it at our evaluation layer, which we discussed all our layers. So here at our evaluation layer, what we can do is we can do prompt tuning. How do we do it? How do we handle prompt tuning overload? So we will add 3 layers. So basically what is, we will create data set based on our evaluation. Then we will create inject based on our data set. We will try to inject few short examples, like multiple prompts we will try with the few shots. Sometimes we inject and test, And how do we do it? We do it automatically, or maybe we will automate it. And based on responses, what we'll do, we will automate scoring pipeline. So in few short or in few short examples, we will just trigger them, and based on that we will give them score, and based on those scores we can say yes, our prompts are getting enhanced and finely tuned. Now we talk about our third uh, pitfall, which is non-idempotent execution. Now, what is non-idempotent execution? So basically, what happens? Let's assume we are working on one of the e-commerce agent, where uh, here you can see we do have order agent, and it has a payment API retry mechanism, which maybe there could be a possibility that payment has failed, and agent will keep on trying, maybe 3 times or 4 times. There could be possibility that behind the scene payment has been deducted at customer end. So in that case, we can say that the system is fragile, and somehow we will have to handle it. Now, how do we handle this problem? In order to handle it, we will fix it at our guardrail layer. Why guardrail layer? Because over there only we have a control where we can either set idempotent keys or unique request IDs, right? And then based on those request unique IDs, we can check or trigger our payment APIs, and then we can see if it happens or not. Because having duplicate requests is kind of a side effect, right? Which will cause an issue in future. So this issue we can handle at our guardrail layer. Now next pitfall is hidden flaws in AI generated code. These days everybody is doing vibe coding. That is a very different example, I would say, but mostly in AI generated codes, the problem what we can see these days is uh, AI layers are generating code, but they are error prone, they are introducing new bugs, and when you review it, you can see few of the features are either not getting implemented or they are half baked. So in order to handle that, we should handle it at our evaluation layer. Why at evaluation layer? Because we can set few pipelines over there, maybe code check, unit test cases, or integration tests, so that we can handle it. If you see this screen here, there could be a security race condition. Maybe there could be possibility that when it is implementing, some old library has been used, or there could be possibility that some wrong component is implemented. So how do we handle? At our evaluation layer, we will set up a evaluation layer, we will set up a pipeline. What kind of pipeline? Once code is generated, we can do static code analysis, maybe with the help of SonarQube, then a security can, load testing, and then once we get all the results, then only we can deploy this code. So this is one way to handle hidden flaws in AI generated code. Now next is latency budget ignorance. Now what is latency budget ignorance? So what happens is, let's assume you are using multiple models at your system, in your system, and definitely since you are using multiple models, there could be possibility you have a small context or small problem or huge problem. So you would like to use complex problems for costly model, and easy problems with simple models, right? So here this latency budget ignorance, if you see here, what it says is we will keep on, I mean, there could be possibility because of wrong implementation, for every request we are either sending large model, which could be slower model, because if you are sending huge object with big context, then definitely model is going to take time. However, there could be possibility that for few of the problems, small model can help you. So how do we handle this problem now? So we should handle this problem at guardrail layer. If we see here, I will just uh, this is this guardrail layer, just so if we see this guardrail and risk layer. Why guardrail and risk layer? So what happens is, Since customer is trying to enter a query, or maybe if customer is not trying, and if you want to do something with your model, first of all, based on context, based on query, we should check confidence threshold of that particular prompt, so that we can identify whether it is a simple query or complex query. And based on that we can decide whether we have to trigger small model or a large model, right? So first of all, at guardrail layer, this confidence threshold will be decided or generated, and then moving forward at orchestration layer, we can decide whether we have to trigger small model or large model. Moving forward, next uh, pitfall is agent failure in real environment. What is, I mean, so agents, these days everybody is working on agents and they are creating agents, but there are problems are, those agents are working fine when demo is being given, but when we deploy them on production, they are failing. Sometimes they fail because of wrong browser selection, sometimes they fail because of older browser version, or maybe different DOM structure, right? So if you see here, the scenario explains it pretty well, where either it is old Chrome or different kind of DOM. So how do we handle it? So this way, what we should do is we should sandbox the entire execution environment at guardrail layer. So in that case, what happens, because we are doing versioning pilling and maybe we do have fallback strategies, so that if particular agent is failing with one mode, it should still work with other mode, or it should raise a flag that it is failing because of these reasons, and then those things can be handled properly. So but basically what happens if you do version billing and fallback strategies, actually what will happen, agent will start adapting unpredictable environments, and in that case it can revive itself safely and automatically. Moving forward, we have next and last pitfall of the day, which is silent model drift. What is silent model drift? So basically what happens these days, models are getting changed frequently. Every day new model is getting introduced. How do we make sure that in this era, or because everywhere people are using this new models, how do we make sure our output of particular model is updated and it is valid and good and it is accurate? So in order to do that, what we should do is we should frequently do automated regression tests, so that we can check for our data set what kind of responses are we getting. We should run weekly benchmark also, I mean, weekly benchmark runs. Based on those benchmarking, so we can see and understand whatever model we are using and whatever real use case we have, are we getting correct response or not. And then if you see here, I have created it here. First of all, we should do automated regression tests, and then weekly benchmark runs. After that, real world query sampling. And this way, we will be able to identify if model is actually drifting, or it is good. Do we really need to replace our model or not? Doing this or doing such kind of continuous monitoring, you will be able to intercept any performance drop or any other issue which may lead to failure of your agent or system. So if based on this, I have created a small cheat sheet here. So for every layer, which layer may have which kind of pitfall here. So if we see guardrail, we, as we discussed, non-idempotent execution, uh, and for non-idempotent execution, we just need to introduce unique keys and then retry, safe check, right? Similar way, agent failure, prompt tuning. So these are all the pitfalls and questions. And then actually if we talk about core pitfalls, so there are only four core pitfalls. Context rot, because based on context rot, if system is not able to remember what was the history, what is the actual thing to implement, then it may cause or it may lead to a wrong output. So for that, memory checkpoint is the core technical fix. Similar way for latency budget ignorance, we will have to decide, right? Because if we start using large language model or complex models for every small problem, it is going to impact the performance as well as costing. So definitely, if we define confidence routing, it will definitely handle this. For, and next is non-idempotent execution, which we earlier discussed, where multiple API calls are being happened, and then how do we handle if we start implementing idempotency keys or unique keys. It will definitely handle things at guardrail layer. And then last is silent model drift, where we have to keep on checking the performance and doing benchmarking of our model, so that this continuous monitoring can help the system. So I guess this is it from the day. And please let me know if you have any questions, or if you have any other major pitfall which we should discuss now or later. Please comment below. Thank you so much. Bye.